Okay, guys, remember I am only going to do a couple of each type. So I'm going to start with number 2. Number 2, actually, you know what? Some of y'all got to number 2. Let's go to number 5 and 6. Okay, so let me grab my pencil. Alright, actually, it's going to be a pen. So first thing we'll do, let's describe it by the equation. So this one means it's going to go left 3. This 8 means it's going to go up 8. It's also going to reflect over the x-axis, be specific, and it's going to vertically stretch 2. So I'm going to go left 3, up 8. And so then at this point, I notice that it should be reflecting down now, so it's going to be going down like this. So it's reflected around this point. I'm also going to stretch it by 2. So at this point, I'm going to go down 2 over 1, down 2 over 3, and that's good enough to have enough on the test. So notice that the 135 pattern does not change because that only is affecting the horizontal here. And so, but right now, there is no horizontal stretch or compress. So, which is why I go down 2 over 1, down 2 over 3, down 2 over 5, but I don't need to do that many. So then the domain is negative 3 to infinity. And the range gets a little weird, negative infinity to 8. Or you could say x is greater than or equal to negative 3. Whoopsie. And y is less than or equal to negative 8. Not negative 8, just 8. So then let's look at number 6. Number 6 has a, let's describe it. So we have right 4, up 1. Remember, anything inside lies, anything outside is what it is. Anything inside does vertical. Oop, I lied. Anything inside does horizontal. Anything outside does vertical. So we went right 4, up 1. Then I know this negative means it's going to reflect over the y. It also has a 2, meaning it's going to horizontally compress by half. So what happens is this pattern of 135 is affected by this horizontal compression, and so horizontally it's going to compress a little closer and tighter to each other, and not 2, man, 0.5, 1.5, and 2.5. So now instead of having these horizontal distances of 135, it's going to have these horizontal distances of 0.5, 1.5, and 2.5. But the vertical change is still 1. So I go up 1 over half, up 1 over 1.5, and then I should land right on a grid line. So it got squished together a little bit more horizontally. And so then our domain is negative infinity to 4, and our range is 1 to infinity. Of course, you can state it as an inequality, but you don't have to. So let's jump to number 9 and number 11. Cubics are a little easier because it's just a 1-1 pattern between the center point. So this one we would say it's a horizontal stretch of 3 because it's inside, so it's opposite. It's also down 1. So you want to plot that first point of down 1. That's our center point. And so what happens is normally, let me show it in a red. Normally our parent is here. Let me show it in red. Okay, and it connects left to right for the cubic the cube root, not the cubic, excuse me. And so what happens is it got moved down 1, and then it needs to stretch out these 2 points horizontally by 3. So what happens is I'm going to go up 1, out 3, and then I go down 1, out 3. Connected still the same, left to right. My domain is, well, my domain and my range are all negative infinity to infinity. All real numbers. So then if we look at number 10, not 10, 11, man, I'm just on point today. It's going to go right 2, up 3. It's going to reflect across the x-axis. It's also going to vertically, please be specific, stretch 4. So I'm going to go right 2, up 3. And then what happens is this red parent I had up here, it's going to reflect, so these 2 points will flip-flop. It's also going to stretch them vertically up 4. So I'm going to go up 4, 1, 2, 3, 4, ooh, 1, 2, 3, 4, and then over 1, 1, 2, 3, 4, and then over 1. And so I still connect it left to right because it's opposite of my cubic, it's cube root. So we can see that vertically it stretched out, it also flip-flopped, and it shifted, of course. So domain is still, and range is still negative infinity to infinity. All right, we're going to do 1 quadratic restriction and inverse and 1 cubic restriction and inverse, and that's where we will end. Very short video because it's a very short review, but make sure you check all your answers with mine that I send out later today. So let's look at this one. This one's vertex. It's a vertex because we have a parabola here because it's squared, is 4, 0. So I'm going to plot 4, 0. What I'm also going to do is I need to restrict this so that it's going to go, I just want my right side of my parabola because if I have my left side and my right side together, then if I do the inverse, it's not a function. So your vertex tells you where you want to cut off that parabola so you only have one side. So what I do is I use my A, which is 3. I go right 1, up 3, and that's good enough. Okay, so what I needed is I needed to cut it off, and the way I cut it off is I cut it off at the x value here. So that's why this is my restriction. So then in order to find the inverse equation, I switch x and y, and I solve for y. So what I'm going to do is I'm going to divide by 3. I isolate what's squared. And then in order to get rid of the square, I do the opposite of what it's saying. The opposite operation would be square root. So you can leave it x over 3. You can write 1/3 x. That doesn't matter to me. And now this is free of the square. So my last step would be to add 4. Just make sure that it's not looking like it's underneath. So how do we graph this? Well, technically we know how to graph this now. We don't have to because if we have 2 points, if we switch the coordinates, so this is 4, 0. So that would become 0, 4. This is 5, 3 becomes 3, 5. Now, without even knowing how to graph a square root, I can graph a square root by flipping the coordinates. So quadratics have restrictions because they are a U-shaped graph, but cubics and cube roots do not because of their unique points that they have. So if we look here, we have a vertex of negative 3, 4. So negative 3, 4. And so what I'm going to do from here, I'm going to go ahead and cut it off at that x value. It needs to be greater than or equal to negative 3. So I'm only going to graph the right side of my parabola. Oops, sorry about that. So I'm going to go right 1, up 1, right 1, up 3. There is my parabola. So by cutting it off, I know that my inverse will be a function. We can go ahead and graph that. This point is negative 3, 4. So it becomes 4, negative 3. This point is negative 2, 5. 5, negative 2. And if you know the pattern of square roots, you know how to put the other. That's not right. I've totally messed this up. Okay. Let's scratch that off because I have messed up. So let's start over. I'm going to put it on this graph. Actually, let's just graph this one. I've totally jacked it up. That was a cubic, and I was trying to graph it like a square root. Oh well. I at least noticed this is a lesson. Don't write in pen on your test. So, those of you that watch this video can make fun of me tomorrow. So this is 0, negative 1. So 0, negative 1, and it's a cubic. So cubics connect from top to bottom or bottom to top. So, but this one's stretched by 5. 1, 2, 3, 4, 5 over 1. 1, 2, 3, 4, 5 over 1. So this is my cubic. It's super flat. And there is no restrictions on cubics. I'm going to go ahead and find my cube root equation because that is the inverse of cubic. So what I'm going to do is I'm going to add 1. Before I can take the cube root of that, I need to divide by 5. I don't care if you leave it like that. Technically is 1/5 x plus 1/5. That doesn't matter to me. And then now I can cube root it. Make sure you write that little 3 on the cubic. Cube root. So, you could either know how to graph that. You actually do know how to graph that. Or you take these points and flip-flop them. So, for instance, 0, negative 1 is negative 1, 0. 1, 4, 4, 1. Negative 1, negative 6, negative 6. Negative 1. So I connect this one, though, opposite of that one. I connect it left to right or right to left. So again, no restrictions on cubics, but we do have restrictions on quadratics. That seems to be where you might have trouble. Sorry for the mistake. My answers will be sent out later today or have already been sent out. If you need more practice, Khan Academy is excellent, but the problem is I have to assign you practice problems to the topic we're talking about. You have to let me know ASAP. And if it is after, I don't know, 8:30, it's probably not a good chance I will be able to do that for you. Good luck, do your review, and I hope you get hundreds.